Okay, so if you need a refresher, we're going to the DCC. We're going to start in our studio session. You can set this for maybe, 3 hours. Yeah, this can be anything. Just do whatever's available to you. I think you all have access to one of these. Yeah, HIV R25 2022 or CHSI. And then go ahead and create your singularity session. Okay, it might take a little bit of time, but there we go. Okay, great. So I just pushed a few things earlier. So if you like to update your, HIV workshop repository, make sure you're on the correct project, which you can see up here is 2022 to 2023 HIV workshop. And we're going to pull in some edits from GitHub. So what this is going to do, once you press this blue arrow, is, for me it's up to date, but for you it's going to pull in some edits from the remote repository and update your local repository. Okay, so I can do that. And if there are any errors, let me know, because it's possible if you've edited one of the files directly that you might have an error pop up. The graph on the screen. Okay, yeah, question over there.
Deleting files and stuff, but I'm not really sure what I can that like to keep for the rest. If that makes sense. So they were saying like
yeah, I think that's for people who do large data sets systems, because like I worked on large single cell data. Like what we're doing in this class is not like I have terabytes of data.
No, too. I understand.
I was like, oh no.
No, this is not the issue. Okay, is there one that no.
I'm not sure if it's yeah, it was good. Oh, okay,
Yeah. All right, any questions for people? Yeah. Oh, okay. Sorry, wait a second. 1 second. Okay. Screen. Does that look good? Yes. Okay, thank you. So some of you are getting an error which says that files will be overridden by what's on the remote repository. And this happens if you had made changes to any of these numbered files. For example, like this O3 dplyr.rmd. So the issue is that your file on your DCC has conflicts with what's on the remote repository. So what you should do in this case, at least for this class, is that you want to overwrite what you have on your DCC with what's on the remote desktop. So in order to do this, it's a quick and dirty way of doing it, I think. Go to your terminal and type in git stash. So what this does is it's going to temporarily store your local changes in another, well, I don't have any, but I think if you do have an error coming up, then you should have changes that you can stash. So that stashes those changes that you have on your local repository in another copy somewhere. It's temporary. But once you do that, and if you press pull, then it should work because you're kind of saying we're going to throw away my local changes and replace them with my remote changes. Yeah, did that work out? Yes, that worked out for someone at least. Yeah, for sure. Oh, it probably is the. I feel like I can't do this about stopping share. Okay, I'll stop share. Is it the sound?
Okay, so it's very top, the second
Very
option.
Okay. Okay, great. Thank you.
Sorry.
No, it's not good. Are you okay?
So there's either in update this one. Is it?
Okay, just wait a sec. Yeah, so that's the same issue.
Okay.
Okay, so again, go to terminal over here,
Okay.
and then git stash. And then press enter, and then you can pull using the blue arrow up here. Okay, so I think everyone should be up to date on that. And now we can talk about what we're going to talk about today. We're going to talk about tidyverse and data wrangling. And it's been a week or two since we last met up, so I first want to go through a brief overview of what we talked about 2 weeks ago, which is just basics of programming and R. So it's a very brief programming review. We can think of programming as a language. And yes, this is our TA and future instructor for, I guess, other sections of this data wrangling or data science workshop. This is Janice. Hi, everyone. Yeah, she'll be helping out today. So, remember that programming is analogous to a language, right? We have things that are kind of like nouns, which we call objects, and these include things like numbers, characters, and more complicated things like lists, vectors, and data frames. And we store these nouns, or really give them names, give these objects names as variables. So we went over that last time. We also talked about how to do things to these objects, using what are called functions, which are analogous to verbs. So these functions come in a variety of forms. There's some built-in functions like take the meaning of something, and that functions just mean you put whatever you want, take the meaning of inside the parentheses. We also have important functions from libraries, and we're going to talk about a specific library today, or a universal library called tidyverse. And what tidyverse allows us to do is it allows us to make some really nice clean data frames. And it allows us to summarize and organize our data in a way that's more amenable to visualization later in analysis. So we'll be talking about one of these verbs today. Are there any questions or something to review from last time? No? Okay. In this case, we can start with, let's see, which one is it? I think it's O2. Yeah, O2, look for O2 tidydata.rmd. And I think like last time, what you can do if you want to make changes or notes is you can make a copy of this. So go ahead and make a copy. And then you can title it anything as long as it ends with capital MINE, underscore MINE.
I didn't see that.
So go to.
If anyone needs help, raise your hand. Yeah, go ahead. Yeah. That doesn't matter. So, it's not really, let's make sure. It's not.
Data science individual.
Yeah, there you go.
I'm just.
Yeah.
I have my. Like, so I just.
And and it doesn't matter what you call it, as long as it's not the same name.
Yeah.
Yeah.
Install.
Yeah. that's just like
Okay. More people?
Oh, okay, yeah, this is a data science, go into that directly. And then probably, right, there are. There you go. Okay, so just.
Yeah.
And then we go over there, like, more, oh, obviously, more, and then.
Oh, no, and then. We close it out. Okay, so we can now start. If everyone's up on, yeah, if everyone's caught up. So I'd like to say that these slides are for this HTML markdown is all pretty much all Janet over here. So if you have any questions, she'll definitely be able to help you. So we're first going to talk about what are the special things about tidyverse, which I think might get a little bit confusing if you know enough of that functions. We're going to talk about pipes. So remember last time we learned that we could do we can put together functions and objects like this, for example, like where you have the function mean and you have some sort of vector of numbers, for instance. We're going to flip this on its head and make it a little easier to read by using something called pipes. So what we would do instead of doing the object side of the function is we do the object first. It's not a very good pen, but we can still see. We're going to use something called a pipe to connect it to the verb. So these two are equivalent. The bottom way is the way that people like to write it in tidyverse. And I'm sure some of you might be thinking at this point, why do this? And the answer is, this comes into handy when we are trying to do lots of functions to an object. So let's say we want to take the mean of this and then apply some sort of function to it. In that case, we'd have to do another function here. Let's call it just function 1. And we keep on enclosing, I guess, nesting these functions within each other. So we're going to do another function like function 2. We'd add another function like that. So the nice thing about tidyverse is that this allows you to kind of better see what order the functions go in. So here, we first take vector num, which is our vector of interest. We then take the mean of it, and then we do function 1. And then we do function 2. So you can see this is a lot easier to read than looking at this. For this, you'd have to say, oh, what's in the very center of these parentheses? It's a vector node. Then you do mean, then you do function 1, and then you do function 2. But for this, it's very straightforward. It's in the order in which it's evaluated. Okay, any questions on why we use these types? Okay. So we can talk about some examples that are in this R&D. So you can see here that we have this data set called Iris. And if you want to take a look at it, go ahead. You can just scroll down to Iris. You can do things like copy. Well, actually, you can probably just run this. Yeah, I can start by first running this to load a tidyverse library, which you can see it is doing for this library command. So this tells RStudio that you're going to be using the tidyverse commands in this RMD. So yeah, press that play button, and then now you can go ahead and just press play on the Iris head. Oh, or this code chunk that starts at line 24. Yeah. So if you want to take a better look at what Iris is, go ahead and type it into the console. And let's use this pipe actually to do something. So let's use this pipe to make it pop up as a data frame that we can look at in like entirely. So if we do Iris pipe view, I don't know if you can see it, and you press enter, then it's going to pop up in the top left-hand corner, and you can scroll down and see all of the values. Okay. Yeah, any questions? We just use the pipe to view Iris in its own little data frame at the top.
It looks good now, but I got rid of the console somehow.
So you have an extra less greater than sign?
And
Yeah, so it's 50%. Yeah.
there you go. No, just.
Yeah, go ahead and install. Yeah, so recall that last time we briefly touched upon how you need to both install a package and load it. So you only have to install a package once. And if you don't, it's already installed actually because it should, at least it should be installed, which is actually kind of weird, it's not. But it should be installed. If it's not, then you could always do install packages, tidyverse.
If it's not installed, they're not on the right container.
Yeah, that's okay. That's fine.
Oh,
And then once it's installed, every time you want to use it in a session, we do library tidyverse. Okay, so back to Iris. So Iris is a data frame of different Iris species. And it's a pretty prevalent data frame that a lot of people use in learning data science. So we have the sepal length, width, and a petal length and width. And we're going to use this in this O2 tidy data just to demonstrate what tidyverse does. Okay, so you now have looked a little bit at Iris, and here we're just getting comfortable with pipes and some very basic tidyverse commands. So if you want to see just the first 10 rows of Iris, or 6 in this case, you can use the head command. So here, go ahead and run Iris pipe head if you haven't already. So in the RMD, as a reminder, you can press Control Enter if you want to run just one command or one row. So here you can see it prints out the first 6. You can also change the parameters or specifications of these functions and have it print out more rows or less rows. So here I just printed out 10 by adding the parameter n equals 10 to the head.
You should be in.
Yeah.
Okay. Yeah, go ahead and do that.
Okay.
That's why you're ready.
Can you go back?
Is that just demand? A different container.
So you should have the.
People are going into the wrong studio.
There.
Some people are. So if they're not, if the tidyverse isn't loading, they're in the wrong. computer.
Okay, so we have to.
They have to use the one for us, so if you go back to where you launch, there you go. So, oh yeah, it's not that, it should be this one,
Okay,
right? I'm pretty
think-
sure
I think
that's
this
the one we
one-
were using.
yeah.
Because our studio singularity, yeah, so it's just CSHI. I could be wrong about this too.
Oh, yeah, it's okay. I don't.
This one.
Is this one? Okay.
Because that will have, I guarantee, whether we intended it or not, that will have all the packages.
Yeah, great.
Because the R Studio Singularity is not, that's a generic one for anyone on ECP.
Okay, that's good
This
to
is
know.
only for the court.
Okay, so if people are having issues, then go ahead and we just make a new session, I guess, using this CHSI Art Studio workshop. And you can
The
find
file
that.
space will all still be there, it's that persistent.
Okay, that's good. I didn't know that either. Go ahead and try the CHSI Art Studio workshop under community apps, and then make a new session. And then that should be loaded in.
For us, it's more than that. It's
I feel like there should be actually an HIV specific one, but I didn't see it on yours, so I'm looking up to.
Yeah, I didn't get access to that, so.
Let's see, Josh normally does create.
Oh, just kidding.
But the R Studio, CHSI R Studio workshop.
Okay, yeah, go ahead.
I have to close the R now and I have to. Because I don't have problems now.
Oh, you can just your phone. Yeah.
Yeah, okay, good.
So when you do the iris type view and it popped up as a frame, is that like a similar function? Because I have a bunch of stuff that I have done before and when I make data.
Okay.
I use this function, but it, when I was able to like name the data.
This is base R manipulation,
Yeah.
but it's not you.
Okay, so going. Well, no, but the one we used here was view, and it created a data frame. Oh, it didn't create a view.
You, if you're looking at. the
Okay, so this isn't, I was wondering why it was.
I was
showing up in the
up
environment. Like,
Oh,
Yeah.
because it's a built-in R data set, so it's not showing in, in there, but it actually is.
It's
inherent in there.
Okay, you don't have to load it into.
No, yeah, basically they load it when you call it now.
Okay. Okay.
It's always that.
Yeah.
And I was often in charge of contact all of them.
Okay. How are people doing? What are these people doing? I'm gonna say we can probably move on for now. So we talked about looking at head, using pipe for head. And also changing what's in it. For example, yeah, head equals. Yeah, 2 or something. You can change whatever. Yeah, I have 2 opens. Let me just close this really quickly. Okay. So we can get a glimpse at a data frame by doing either head or by doing view, for instance, like we did earlier. We can talk about more verbs than we can do a tidyverse. So one of them is sample _n. And what this does, as the name kind of implies, is that it just takes a data frame and samples 10 random rows. So you can go ahead and run that. And I'm sure you can also change number, like you can do maybe tree, not fruits. So this is a good example of when to use the question mark command to make sure that we are giving sample n the correct parameters or arguments. Also looks like it's been superseded. It's size, not n, so go ahead and type in size equals free. All right. And an example of using multiple functions for this pipe is in the line below. So here, we first take iris data set, we sample 10 random rows. Oops. We then take the petal width column, which we denote using the $sign. And then we take the mean. And for those of you wondering what this dot is, this dot just refers to everything before the previous item. So it refers to all of this. So what it's doing is that it's just taking these 10 samples, and then it's going to get the petal width column from it. Yeah, there you go.
So it's taking 10 samples, why is it only getting back one number?
It's gonna be that one number because it's first taking these 10 samples. It's taking the petal width column, like for example, I guess it would be 10 of these, and then it's taking the mean of those 10.
So one way to like really to work this out for yourself is to execute one at a time and see what happens. So to just like execute iris, sample n of 10 and see what you get. And then execute the next part, the iris sample n 10 and then dot petal width and see what you get. And then so it to just kind of break it apart step by step for yourself.
Yeah, that's a good point. Thanks, Janice.
And that's also how you write it too. Whenever I write code, I write the first part to see what I get. And then I put the second part on and do what I get.
That's good practice for
Yeah.
sure. So just to demonstrate what this would look like is you can highlight iris, you can press Control Enter for me, and you see this data frame that's 150 rows by 5 columns. So now we can try and see what sample n does by highlighting that. Control Enter, and we see 10 rows by 5 columns. Okay, let's just see what petal width does. This $sign petal width. So this takes the petal width column and changes it into a vector. And then finally, if we run the whole thing, it gives us one number, which is the mean of what we saw previously. Okay, so just to give you an idea of how much more readable tidyverse is than normal R in these situations, I can just type this like we were doing in base R. So in this case, it'd be something like,
It's actually the next line.
sorry,
It's the next line.
what's the next one? Oh, it's over here. Yes. Great. So this is an example of what it would be if we did not use pipes. So I guess you'd have to read it something like it's the mean of the sample, like of 10 samples of this iris, but you take the petal width, which is a little bit confusing for sure. And this is a lot more straightforward. You take iris and you sample 10, then you take the petal width, then you take the mean of that. Okay, so now we're going to do some exercises, or one exercise actually. And we're going to use a data set called empty cars. Let me just make sure that it comes up. Yeah. So if you type in empty cars, just into the terminal or console, sorry, then you can see this data frame come up. You can choose to view it using the pipe again, or look at the head and so on. But your exercise is you want to use the pipe to get the average miles per gallon in the empty cars data set. And the miles per gallon is this MPG column over here. Okay, so we'll give you a few minutes to try doing this, and we'll be coming around if you have questions. How's it going? That's a good story. What's the first? Yeah, it's first against off of what's. Oh, yeah, definitely. Yeah. Okay, it looks like most people are done, so we are going to just go over the answer to this and then move on. So we're gonna start by looking at the empty cars data set. And then we're going to get to the miles per gallon column. So we're going to do that using a dot, MPG. And then we're going to get the mean. And that's it, we're done. Any questions on what we did here? Yeah.
Where would you like refer to know?
Yeah, so I don't think, yeah, so that's a good question. These are base R functionality things. So I don't think you'd be able to do this using a question mark, yeah. So what I would suggest doing in this case is just going to Google and Googling it. So actually, there has been some update to tidyverse, I think, and you can just about using a dot or dollar sign. So what you could do, I think, is use the pull command. It actually do the same thing. Just make sure. Yeah. But this dot dollar sign was what was mostly used for a very long time. Okay. I'm gonna move on. If you have questions, feel free to ask Janice or I. Okay. So we're gonna talk now about what tidy data frames are. And I think there's a nice PNG that will show, that demonstrates what that is. So I think a lot of statisticians, a lot of what our work consists of actually is getting our data into what's called a tidy data frame, which means it's useful for analysis and we're able to manipulate it very easily. So we're going to look at, I guess, an example of what it means to be tidy. And if you knit if you knit this, then you should be able to see the nicer full picture of what it is. So tidy data has the following format. Here, each row corresponds to an observation, and each column corresponds to a variable. Each entry or cell tells us what the value of each variable at a given observation is. So one problem is that a lot of times we get untidy data from investigators. And here's some examples of what untidy data looks like. So in this case, we're looking at, I think, some data on countries and cases of a disease, probably AIDS. And we can see here that we have, we do have a column per country here. But we also have, I guess, these columns for type and count, where type really encompasses two variables: number of cases and population. And count tells us, for example, how many cases are in Afghanistan and what the population of Afghanistan is. So I want to see, okay, it's fine. So in this case, what a tidy data frame would actually be is you would have these four variables: country, year, cases, and population, and you'd have, I guess, an observation for each country, year combination. Are there questions on that first example and why it's not tidy?
I have a question.
Yeah, go.
Is there any way to convert a non-tidy format to a tidy format?
Yeah, and that's what we'll be doing for a lot of this, for some of this lecture at least. Yeah, in the next lecture as well.
Within our environment, right?
Yeah, that's right. Yeah, good question. Okay, so another example of a non-tidy format would be like this. We have country and year, which is good. Those are our observations of interest. And we now have the rate, which is cases per population. And this is difficult to parse because we have this character string of numbers. And we have to separate this number of cases from the population in our final analysis, most likely. So this is not good either. This is not tidy. Okay, here's another one, which, yeah, you have, I guess here you have countries and you have different years as different variables. I think technically this is tidy if you want to look at just the number of cases, but you'd also have to find a way to incorporate the number of population, I guess, within each country in each year. And that would require more columns, and it becomes using columns like that. And the same thing here. Okay. So again, our goal is to have variables and in each column and observations in each row. And a lot of what tidyverse does to help us is it gives us verbs that allow us to convert this untidy data to tidy data. Okay, so we can start talking about how to do that now. So I think this, yeah. So we're going to start by using just a very basic data set that's very short. So what this code chunk does is that it creates a data frame. And you can see that these are the column names, and what follows are the column values. So this is PID, which is patient ID, and we have 1, 3, 4, 5, and we have some descending variables, which are, I believe, gender and age. We have visit 1, which is a value corresponding to their first visit, and we have visit 2 corresponding to their second visit. And notice that we have some missing data, which in R is coded as NA in the data set as well. Okay, so this is what we'll be starting with. Feel free to go into your RMD, not the HTML, and run that if you haven't already. Okay, so I'm scrolling down to where we're doing this. So make sure you put everything above. And then we're going to run this. So we have a few issues with this data set as it is. It's not very tidy. So one problem is that each row has 2 observations. So that just means that we have visit 1 and visit 2 as separate columns. What we'd really like us to have maybe 1 visit. Well, I guess these values refer to the same sort of thing that's being measured, right? And we want them to be in a single column. Does anyone have questions on why we want that? I feel like that could be a little bit, I need some of this, that's why. The reason is, if we wanted to take, I guess, averages of this value over multiple visits, it's a lot harder to work across columns than have it in 1 single column. And by having it in 1 single column, you can still kind of see what visit refers to by having a separate column that labels this is visit 1, visit 2, visit 3, so on. Okay.
Yeah, I also just want to point out too, all of like sort of the tidyverse universe expects this kind of format. So if you run ggplot, for example, maybe you want to plot a trend over visits, right? So you can actually you'll see later when you learn how ggplot works. It's very easy to separate out the visits by color or whatever by just saying, color equal visit, and then we'll give you 2 separate plots on the same axes.
Yeah. So yeah, making data tidy is good, not only for, I guess, analyses across different time points and different, I guess, other things like gender or age, so on. It also is good toward the rest of tidyverse, like plotting and analyzing data. That's how it expects the data to be formatted. So again, we want you to combine this visit 1 and visit 2 columns so that we have 1 column of values and 1 reference column of what visit corresponds to. So this is probably one of the more complicated commands in, I guess, tidyverse. But this thing is called pivoting longer because we're going to take these columns and we're going to kind of pivot it so the data frame is long instead of wide like this. So just to give you an idea of what it looks like, go ahead and run first before I explain what's going on. And you can see that this outputs a tidy format. So we now have a measurement column and we have a visit column, which lets you see whether the measurement corresponds to visit 1 or visit 2. And what this pivot longer command does is that it first selects which columns to pivot. In this case, this is columns visit 1 and visit 2. And once it knows what columns to pivot, it's going to take those columns and look at their titles. in this case, visit 1 and visit 2. It's going to put these titles in a separate column, which we'll call visit. And it's going to put the values in these columns in a column called measurement. Okay. So let that sink in for a little bit. If you have any questions, just let me know. Okay, so we've talked about pivoting wider. So now we have a measurement row and a visit row instead of visit 1 and visit 2. Another problem is that in this DESC, we have 2 values that we're interested in. We have gender, and we have we have age. Yes, we have sex and age. So what we can do is that we can try to separate these out into 2 columns, 1 for sex and 1 for age. So we are going to just run this and see what happens before explaining. So now we see that we have a sex column and an age column for a variable. And the way this works is that we first take our pivoted longer data frame. So the one with the measurement and the visit column. We pipe and do something to it. And this something is separate. So what the separate command does, well, I should probably go over to, I'll go over to later. Is that it takes the DESC column and it looks for a separating string. And it divides whatever is inside a DESC column using the separating string. In this case, it knows that there's a separating string dash between this capital letter and these 2 numbers. So it's going to separate into 2 columns because there's 1 separating string. And these columns are going to be called sex and age. Yeah.
So for what's the difference between like the 1 quotation mark versus like the 2 quotation marks here? Like you have like the dash only has
Yeah. I don't think there's that much of a difference, right, Taylor?
There's none.
Yeah, there's none at all.
Absolutely none.
Mhm, yeah,
Backtick is different.
yeah,
but
that
yeah,
is different.
there's
That's up here.
And it's. And that's my sloppiness where I put sometimes single, sometimes double,
Oh.
I don't feel it.
It's all good. I do that too. So just as a caveat, I'd like to talk about the structure of the player of the pipe in general, actually. One thing I forgot to mention is that this pipe, if you look at the documentation for all these dplyr verbs, like for example, pivot longer, you'll notice that it takes in a data column, a data parameter, columns parameter, and so on. But here we were missing a data parameter. We don't ever specify data equals something here, right? But that's because what the pipe does is that it passes on this preceding object and designates it as the first parameter in this next object. So if you just look at this df pipe pivot longer, that's the same thing as saying pivot longer df calls equals visit 1, visit 2, and so on, right? So this pipe just takes whatever's preceding it and plugs it into the first parameter argument of the next function. Okay, so we've talked about that. And we know about separate now. And I think we've made a lot of progress in terms of how tight our data frame is. We can see that it's pretty much tidy. We just have this missing argument here, which we can talk about later. But each column corresponds to a variable. And each row corresponds to one observation. Okay, are there any questions on this pivot wider command? Or separate? Okay, if not, we can keep on going. And we'll take a break at the end of this RMV. So now we can talk less about necessarily tidying data and more about isolating variables that we're interested in. And also kind of changing variables if we want to. And making new variables. So if you look at this data frame, it's pretty much tidy. But one thing that's of concern is that this age variable, you can see it's a character or it's a CHR rather than a number. And we want it to be a number so we can look at means, for instance. And there's also this missing argument or measurement over here that we should take care of. So what we can do is we can make age a number. And we can tidy up the data frame a little bit more even. We can make visit a number. And we can also drop the NA measurement. So just running this chunk, you can see now that the NA measurement is gone because we've got rid of the row corresponding to that. You can also see that age is now an integer and that visit is also an integer. Recall last time that there was visit, like the string visit in front of all of these, and they're now gone. So all this is what we did before. So we can look at what follows. So we first, let me just highlight this again. Once we finish tidying most of it, what we're going to do is we're going to make age into an integer. And we do this by using a mutate function. So mutate lets us mutate certain columns. In this case, we mutate age and visit. So here, we mutate age to be equal to age as an integer. This as integer function forces age to be an integer, even though it's a string right now. We can also mutate the visit column to remove the visit string in front of the visit number. And that's what this str_remove does. It takes the visit column and it removes the string visit. Finally, we take this visit column again, and we make sure it's an integer and not a character. So just running this, we can see that now there's no visit in front of the visit, and these are both integer columns, age and visit. The last thing that we do is we drop the NA. We drop the NA observation. So this drop_NA takes a data frame and drops any observation that has any NA value in it. In a specified variable. And if we assign this to the variable df1. Okay, are there any questions on what happens here? Okay. Yeah, we can talk about joining data now. This is going to be a lot of information for you guys, so if you have any questions, please feel free to stop us. But let's say we have this data frame, which is nice and tidy now. And we'd like to add some new information from another data frame. Let's say that we have the names of the people, but they're in a separate data frame called names. So if you run it, you can look at names. And it's just their patient ID and a first and last variable name. So what we can do is we can join these names to our existing data frame by using some commands called joins. There are different types of joins. So there's an inner join, left join, right join, and full join. And these kind of do the same thing. They join two data frames together, but they have different specifications on which rows to keep. So this inner join, you can see joins. Yeah, I guess it joins. Sorry, this DF is the original untidy one, but the same thing applies to our tidy data frame. So you can see that the two data frames, names and DF, have only the PID column in common. So what this does is that it looks at the PID column and the corresponding first and last name, and it joins it to the DF, this DF data frame, using this PID as an identifier. So that's why this PID one, this data frame row is connected to, I think, was it, yeah, Bob Lynn. And what inner join does is it looks at only the PIDs which are shared between both data frames, which in this case doesn't really matter because we do have all the PIDs. We have 1, 3, 4, 5 in both names and DF. We also can look at left join, which keeps all the rows in DF, but not necessarily all the rows and names. For example, if we had a PID number 7 in names, but it didn't show up in this data frame, we would not have a PID 7 in a joined data frames. Right join is the same thing, except it keeps all the rows and names and not in data frame necessarily. For example, here you can see that there are PIDs 2 and 6 in a names data frame, but not in a DF data frame. And as a result, there's no data for Dan Tan and Jen Finkelstein. And we replace all of these unknowns with an NA in a joint data frame. And finally, full join keeps all of the PIDs, regardless of whether they are names or DF. So these are a lot of different ways of joining data. And if you're confused about what exactly they do, you can look at the documentation. But just know that it refers to which rows to keep based on the identifying variable, which in this case is PID. Okay, so I think your exercise that we can do now is try to tidy tables 2 through 4B, which were in, I think, way up there somewhere, and which had to do with countries and cases and populations and years. So I guess part of your job is to think of what does a tiny data frame look like and big hints. I think an example of it is actually the I guess graphic over here. And then try to get all of these tables into that format. Okay, yeah. We'll be walking around to give questions.
What was 701? Was it theory? It's pretty important. I miss the students. That's nice. Yeah. You have the R25, she teach, I guess. Yes, my teach the yeah, in this. That's a workshop series. Okay. So it's another like the 2 weeks. Oh, this is, and then I have this. Yes. I'm working on this slowly. And then basically bring your own data. Yeah. I think Richard is asking for the next one. Yeah. Right. And then it's like, are you getting where? Yeah. I think the schedule is on the. It's on. Yeah. We can hide that. Okay, then I can find it. So. Yes. Right. I just yeah. Years. Is it it's cases? Yeah, cases on population, and then there's a count, right? So basically, what we don't want cases in population with that, you want it to be wider. So you want a column of cases in a column. We haven't talked about that. What? Yeah. Oh, okay. That's my bad. No, it's all good. As a hint for table 2, try looking up pivot wider.
It's the opposite of
It's the opposite of pivot longer. Could be confusing.
It's better than gathering red.
Yeah, that's true. Yeah, go ahead. Yeah. No, sorry, no. Rows. Doing table of full table. Okay, just as a further hint, I think these are the verbs that you want to use. Sorry, the functions that you want to use. You want to use pivot wider for the first table, separate for the second table, table 3, and some sort of join for the 4th table. So try to fill in the blanks if you can. And these should be the only things you need for pivot wider. Oh, in here. Yeah. Oh, yeah. There it is. Okay, we're going to stop. Does anyone want to tell me what they put for the first table, table 2? If anyone got there? Names from type. Okay, names from type. I don't remember what the casing was on this. Yeah, okay, great. How about values? Count. Yeah, okay. Great, that's perfect. So we now have 4 columns: country, year, cases, and population. Okay, let's try table 3. I have part of the answer written out here. What am I missing? This is a separate command. I'm telling it that we take the rate column and we want you divide it into cases and a population column. But I'm missing something. Set. Yeah, great. Need to tell it what to separate by, which in this case, I believe is the, yep, yeah, that function, the divide function. And we have the same sort of tidy data frame resulting from that. Okay, we have table 4A and 4B. We want to combine them because we have cases in one and we have population in the other. So let's try interjoining them and seeing what happens. Interesting. Doesn't like that. So we can't just interjoin them. And the reason is I believe there's a 1999 and a 2000 column. So first, what we have to do is we want just a year column and a count column, or I think this is cases. So this means that we should pivot longer. So we pivot longer. We specify what columns to include. And in this case, you want to pivot these 2 columns to 1 column. So we're going to give it that parameter. We have names 2. We'd like the names of the columns 1999 and 2000 to be year. And we'd like the values to be called cases. So now it looks a lot more tidy. And it's table B. I don't remember what it's the same thing, but I think it is.
It's the same thing because of population.
Great, thanks. We do the same thing, but this time we rename the values to population instead. And so now our goal is to combine these 2. So what we can do is we can take table 4A with all these modifications. And we can join them, join it to this table 4B with all these modifications. So let's see if that works. It works.
So in this case, for better readability, I would suggest saving table 4A modified and table 4B modified, and then doing a join. That way, yeah, that way it breaks it up a little bit.
Good point. So what we could do, as Jan suggested, is say table 4B as a variable, table 4B.
Underscore tidy, yeah.
Yeah. Now we can do the same thing with table 4A. And then we can now inner join like this table for A tidy and table for B tidy. And as a reminder, it's the same thing as table for A tidy and piping that into inner join table for B tidy. All right, any questions? Yeah, if not, then it's break time. And we'll be back to do more work with tidyverse and then more fun data set hopefully. So see you after the break. If you're making it until, yeah, the 25. Yeah, 10 minutes. Okay, so for this tidyverse practice, we're going to be using the Star Wars data set, which is just a big compilation of Star Wars characters and some basic information about them. So yeah, go ahead and make your own copy of O3_dplyr. And just for some background, dplyr is one of the libraries inside of the tidyverse universe. So the tidyverse universe is actually a big compilation of different libraries. We have ggplot for plotting, we have dplyr for wrangling data and making it tidy, and we have other libraries as well inside this tidyverse. So we're going to do some more work with dplyr. And this is less tidying the data and more exploring it and summarizing it. So we're going to start first by talking about looking at specific variables. And we do this by looking at using the select command. So let's start by looking at Star Wars. We can again use Star Wars view to look at the data frame. Let's see what happens. Star Wars view. Did my session expire?
Go to the, yeah, jobs probably, or interact.
I think there's a good way of seeing it to this. Okay. Has anyone been able to get Star Wars? Okay, everyone's fine then. You can go ahead and run Star Wars head. And that again returns the first few rows. And what select does is that it takes the first, I guess, column names that are inside of it. And it just displays those when you run. Yeah, let me go back, multiverse now. Star Wars 10. Okay, I think it works. That's good. So Star Wars head returns the first 6 rows, and we see Star Wars characters, their height, mass, a lot of information on what species, what sort of home world they're on, and so on. Yeah, lots of information. So what we can do is we can play around with the select command, which lets us select certain columns. So you can look at here and see that this selects only the name column, birth year, and species. So if you copy and paste this into the console, you can see it just returns the first 3 observations and these 3 columns. We can also, yeah, let's see what the next one does actually. The next one's almost the same, except we rename birth year to be age. So we can see now that before we had birth year, we now have the age column. It's the same thing. We can also select all of the columns except for these 3, which we can do by using the minus sign in front of these column names. So if you run this, then we get all the other columns except for name, birth year, and species. We can be even more flexible and select all columns that start with S. So the starts with command just takes in a character or character string. And we select just the skin color, sex, species, and starships column. We can get fancier and look for columns which match a specific word pattern. In this case, this word pattern is, I believe, anything with consecutive vowels, sorry. So we have here EI in height, AI in hair color, EA in birth year, and IE in species. And this sort of string matching can get pretty complicated, but it's pretty fun once you get the hang of it. There's some websites which let you kind of play with patterns and see what you can match. Okay, so we can also do things like arrange data frames and sort them. So in this case, we look at Star Wars name, age, and mass, and we arrange in, I think, yeah, increasing order of age. So we have the youngest Star Wars character first and the oldest last. We can do it in a reverse order by using the DESC command, which stands for descending. So here we're going to have the oldest first and the youngest last. And the oldest Star Wars character is Yoda. 896. See. It's the same thing. Yeah, I think it's the same thing, except we look at the first five. So I'm gonna skip this. You can also arrange by 2 columns. So here we arrange by increasing age. But if people are tied, like for example, Leah and Luke are the same age, then we put the lightest person first, then a heavier person. Okay. And we can use the select with other dplyr words. Like in this case, we're looking for like people who are, yeah, the oldest, I guess. Top and equals 3, but not necessarily in order. Actually, yeah, in order, that's true. All right, are there questions on selecting? It's pretty versatile. I can select lots of different columns using column name or column pattern, things like that. Okay. So I think the next exercises have to do with the diamonds data set. And they're mostly selecting and arranging like we did before. So if you pull up diamonds, you can see they're just yeah, 53, almost 54,000 diamonds. And they have information like carat, cut, color, price, etc. And we're trying to understand some basic information about them. So yeah, go ahead and select and arrange. If you get questions, we'll be walking around. Okay, let's go over to answers to these quickly. So the first we want to select X, Y, and Z. We can do that by selecting X, Y, and Z using the select command. And you can see that it prints out only X, Y, and Z for all observations. So now let's select everything except for price. We do that by using this minus sign price instead of select commands. Yeah.
For the first one, how do you know when to put the quotations around the variables, I guess,
Yeah.
within the parentheses?
So for these deep flyer commands, you don't have to usually put down there like that. I think the only time when you need to is maybe when you are using some sort of vector like this.
Oh, okay, okay.
Yeah, and there's a lack of consistency in R these days with when you need to specify columns using using quotations versus just the names. And if you think you're doing everything right and it says not found, but quote right.
Okay.
Okay, let's talk about how to find the most expensive diamonds. We used our range command, but know that the range command by default source it in increasing order, not decreasing. So we just specify that we want it in increasing order of price. And that should give us the most expensive diamonds. And yeah, in decreasing order. We want the first top 5, so we should also add a head 5. And that gives us the most expensive 5 diamonds. Okay, let's try the least expensive diamonds, 5 diamonds, and only carat cut, color, and clarity. I wonder if anything else starts with C. Probably not. So we can first arrange by price. And then we can select only the columns that start with C. Yeah, that looks good. And don't forget to look at only the 5 least expensive ones, so we use head 5. Okay. Yeah, question?
For the top 5, can you use the same thing that we did for the Star Wars one, where if we showed the top 3 oldest Star Wars characters?
Oh, this top end?
Yeah.
You definitely could. Yeah, good catch. So great. As it's been pointed out, you could just do this too. Top end. 5.
Which I strongly suspect is a wrapper for the other code.
Hmm.
So when top N, that function is probably just exactly the code that is above. Makes sense. What? Top N probably uses, never mind. it's not
Oh, it
important.
uses this. Okay, okay.
Yeah.
I got you. Yeah. All right, so Janice like hypothesizes that this top end 5 is just shorthand for this Disney player. I wonder if there's a way to do the next one in the same way. Yeah, select top or bottom. Okay, it's been super smooth. Okay.
Yeah.
A lot of yeah, just as a just as a remark, this package changes quite not frequently, but it changes over time. So when you say something that's a superseded, it means that they prefer you to use something new. In this case, they want you to use slice min and slice max. So in this case, for diamonds, the least expensive ones, you would do slice min 5, I think. And the rest can be the same. Sorry, just this select thing can be the same. Okay, yeah, I should look at documentation. Slice means you should order by something. So I need to tell it to order by price. And n equals 5. Okay, so yeah, when looking at how to use functions, it's always good to look at these arguments. In this case, I know that this n is relevant because we need to know how many we want to display or get. And we also need this ordered by. Yeah, ordered by parameter, which tells us what to order it by. So again, I guess looking at the arguments, looking at this usage, and looking at the examples tend to be very helpful. Okay. Are there any questions on, I guess, superseded functions or this slice max, slice min stuff that we're doing? Okay, we can talk about the last question, which is 10 most expensive diamonds of largest carat size. So we first want to sort primarily by price. And within price, we want to look at the largest carat size diamonds. So for ties, we want to look at the diamond with more, which is larger. We want price to be decreasing. So, well, I guess I could probably do slice min, but I'll do this first. Okay. Yeah, sometimes you don't remember what column names exist, so you can use this column names to look at the column names for the data set. So we're looking for carat, yeah, not size. Carat and price. Yeah, it looks like it's decreasing in price. And I'm not sure if there's any ties. I think there is actually. There's a tie over here. And yeah, the bigger carat is first, so that's good. So this is one way of doing it. And there are probably other ways you can do using top end or slice max. I think you need a, yeah, okay, order, sorry. Price and carat. Might work on this later. Okay, I'll do that later. But this is one way you can do it. Okay, any questions on selecting and arranging? We're just selecting variables we want to look at, and we're trying to sort by different variable values.
Do you mind repeating why you had to use slice again?
Okay, so you don't have to use slice, but it's just good to because what we used originally, this top end, has been what's called superseded. So if you look at top end, you can see right here in the life cycle that it's been superseded, which means that there's another preferred way of doing what you wanted to do. So here you can see that top end has been superseded in favor of sliceman and sliceman's. So deprecated means that you won't be able to use them anymore. Superseded just means that there's something better that they prefer you to use instead. So that's why we're using slice min and slice max instead of top end. Okay, I think we can now move on to talking about filtering data. So we talked about just selecting certain columns, but what about selecting certain rows instead? Let's say that we were just interested in looking at, for example, all Star Wars characters who are older than 100 years old. We can do that by using the filter command. So here what we're doing is we're taking Star Wars and we're filtering it so that all the birth years are more than 100. There's not too many. There's only 5 people who are more than 100 in this data set. So we can filter for on more than one condition. So you might remember last time we talked about using or, which is the straight line, and, which is the and symbol, ampersand. We can do that in filter. In this case, we can filter so that birth year is more than or equal to 600, or the name is Dooku. So if we do this, then we'll see 2 people who are above 100, and that's Jabba the Hutt and Yoda. We also have Dooku, who is less than 600 years old, but his name is Dooku, so he makes the cut. Okay, so now we can combine filter with select to look at cross sections of data that we are really interested in. For instance, for these 3 people we just looked at using filter, we can look at just their name, age, and homeworld. And we can also filter, in this case, instead of having an and, we can use commas. So here, we're just filtering all male sexed Star Wars characters who are more than 100. Any questions so far about filtering? Yeah.
Does it matter the order if you're doing filter and select at the same time?
No, it shouldn't matter because filter only has to do with the rows and select only has to do with columns. Yeah. All right, here we're getting a little bit more fancy with filter. We can also use string detect. So here we're filtering for homeworlds that have IN in there. And we're just selecting the name and homeworlds and looking at the first screen. So let me just run the first 3 lines. Oops. Yeah, so we have 18 people who come from a homeworld that has IN in there. Okay, so let's do another exercise and then let's take another break. So here we're going to work to the diamond data set again. And now we're going to find diamonds which meet a certain criteria. So this is very much about using filter for all of these 5 questions. Okay, I'll give you a few minutes Go over any answers and we'll take another break. Okay. Also, if you want to look at more information about diamonds, you can use this question mark and then type in diamonds. And you'll be able to see things like what the price range is, what sort of cuts there are, and so on. Which will come into handy for question number 4. Okay, so can people hold up their fingers and tell me how many questions you are through so far? 2, 3. Okay, I'll give you maybe 2 more minutes. Yeah. Okay, we can get started with the first few. So the first few are fairly straightforward, although we didn't really go over this equals this time. We went over it last time. So remember last time we talked about how 1 equals is used to assign variables, but 2 equals is used to determine whether 2 things are equal. So here, if you want to find diamonds whose cut is ideal, we're going to filter for cut equals ideal. So now let's find diamonds with all carats more than 2. So these are large diamonds, or fairly large diamonds. We can just do filter carat more than 2. For the next one, I'm going to ask for someone to give me the second part of this. So if we have diamonds and we want to filter for carat more than 2 and cut premium or ideal, what should I put after this comma? Yeah, right. Cool.
Equals.
Yeah. So this is one way of doing it. You can do cut equals ideal, or cut equals premium. And that will select both. Yeah. Ideal cuts and premium cuts. Another way of doing it is you could use something called an in command, kind of, where you have cut in this vector, either ideal or premium. So what this does is that it creates a vector of these 2 strings or values of interest, ideal or premium, and it filters for cuts which are in this vector, so either ideal or premium. Okay, so that's something good to keep in mind for future use. So for number 4, we have find all diamonds that cut better than fair. So notice that if we look at the documentation, everything's better than fair. So we really need such a filter for things which are not fair, which means we can do cut not equal to fair. And that should work. Okay, the last one is use string select or str_detect to select all diamonds whose cut is good or very good. So recall that string detect, if you look at the documentation, it takes in 2 arguments that we should input. So this says string, it takes in the string and a pattern. So the string in this case that we want you to detect, that we want you to look at, is the cut. So we're going to search all of the values of cut in the cut column. And we're going to see whether it matches the following string. We can just put, well, you can put like, I think G, it should work for GO. So here we're looking for, in the column cut, whether anything has GOO. And we're just going to keep the columns that, sorry, observations that follow that. Yeah, go ahead.
How does it know if you want it to like just include those 3 letters as opposed to that being like the entirety of what it's selecting? If that makes sense.
Yeah, that's a good question. So this string detect is very flexible. It pretty much says if it shows up anywhere, then we're going to match it. If you want an exact match, then that's where you could do something like the matches, use the matches command to, yeah, let's see if this works. Okay, that's not how you use it, but use the matches command.
Okay.
If you want an exact match. Yeah, I'll look at this during the break. Okay, so we now know how to select columns and filter out for certain observations. And we'll now go on after the break to talk about how to create new variables from existing ones and how to summarize these variables. Okay, it's break time. Feel free to walk around. We'll be back at the 4. So we have another 10 minutes.
Oh, I think that's one day night.
What is expand? No, it's not. I mean, I don't know if they can like explain regional now.
Okay, so before we finish the very last part of our, I guess, workshop today, I just wanted to go over a quick summary of what we've talked about so far today. We've talked about how to get tidy data from untidy data. And we've talked about why that's important. So this includes things like pivoting longer and wider to make new columns or split old columns into 2 separate columns. We talked about separating columns, which are divided by a string, separator string. We've talked about mutating columns to become the correct type, like numeric or character. And we talked about joining matrices together. And right now we're talking about ways to subset and summarize data. So far we've talked about selecting and filtering. We're going to talk about mutating and transmuting data, which is adding new variables. And we're going to talk about group by and summarize at the end, which is summarizing data. So things like means, medians, standard deviation, so on. Are there any questions about the first part of this or select filter so far? Okay, if not, we're going to talk about how to make new variables of existing ones, and then how to summarize all of these variables into summary statistics. So to go back to the question that was asked earlier about whether string detect looks for GOO very flexibly or whether it's at the very beginning. If you want to look for GOO at the very beginning, you could do 2 things here. You can either do grepl, which is more, I guess, string manipulation. So again, this gets into kind of complicated territory, but if you're really going to play around with this and do a lot of work with detecting strings, then I would suggest this website. I think I used it a lot at some point when I had to work with a lot of strings and different variables and stuff like that. So basically, as an example, if you go back here, this caret means that it matches at the very beginning of a string. So here it means that this GOO has to be at the very beginning of cut. So this will match good cuts, but not very good cuts, because very good does not start with GOO. So just to be specific about this, This would be the same as, this in a way, as this without the caret. So this without the caret is the same as string detect. Okay, so that's enough about filtering. And we can now talk about making new variables. So this comes in handy if you want to either make new variables or if you want to edit existing ones. So again, let's look at just the name, age, height, and mass. And let's try to calculate the BMI of all of these Star Wars characters using the mass and height. So here there are two ways of doing this. If you want to keep all of the variables that we have in our data frame currently, we would use the mutate command, and we would mutate a new variable called BMI and set it equal to mass divided by height divided by 100, and the denominator squared. Yeah, squared. That's right. And we can see if they are obese by looking for people with BMI over 30. So let's just run this and see whether our first three characters are obese or not. Okay, so Luke and C3PO are pretty good, but R2D2 has a very high BMI. So, yeah, mutate helps us create new variables, but so does transmute. And the difference between transmute and mutate is that you can see that mutate keeps all of these variables named age, height, mass, but transmute will get rid of all of these, will drop them. So if you do transmute, the mutate, you end up with only these two variables. So one thing that we can do is we can mutate or transmute across multiple columns. And there are a few ways of doing this, but the most up-to-date way, I think, is using the across verb. So here, if we want to do the same function, in this case, you want to turn all of our strings to uppercases across lots of different variables. We can use the across function to select, in this case, all of the character variables. So here, what we're doing is we're transmuting all these character variables to the uppercase. And let's just see what this looks like. I'm going to run this in the console. And you can see that all of these are now uppercase values. If you want to only do a few variables, then we can specify them by name. And I know there was a question earlier about when we use quotation marks and when we don't. Here's an example of when we can, although it's not really, it doesn't really matter. It's the same thing as doing this. Yeah, so here we can either use quotation marks or not. We're interested in these three variables. And we can mutate or transmute across just these three variables by using the across command again, but this time we feed it a vector of column names. So for birth year, height, and mass, we're going to add 1 to each of these variables. And this weird squiggly and then .x is shorthand for doing this operation that follows the squiggly tilde, doing this to all of these variables. So .x is a stand-in for each of these variables. So notice here that if we print in the original one, which is just the select command, we can compare it to this transmuted version where we add 1 to each value. Let me scroll up. So notice that all of these values are different by 1. Are there any questions about this?
So what's the meaning of a cross function again?
Oh, the tilde? Like this thing over here?
No, the cross.
Oh, across. So this across function takes a set of columns as this first argument. In this case, it's these 3 columns. In some other cases, you can just do across all character columns, for instance. And that's where it is. That's what this where parentheses is character refers to. It refers to all the character columns in the data set. And then once you have these columns in the first argument, it applies a function to all of these columns. So you can specify the function in multiple ways. The most explicit one would be something like you have this function x, which is this string to upper, for instance. So I know we went over functions last time, but I know it's been a while. So just as a refresher, remember we defined functions kind of like this. So in this case, this string to upper function has been written by the dplyr folk. And it was probably written something like this. So that's probably the string to upper function. And here we're just saying that for all these columns, these character columns, across all these character columns, we'd like to apply the following function. And here, x is just a stand-in, and we plug in each of our character columns into this x one at a time. So this function applies to all of our columns of interest. Yeah, how much sense did that make? Not much. Anyone confused about I guess, does anyone want me to break this down further? No? Okay, someone shake your head. Okay. If no, yeah, sure. Okay, in that case, I can just erase part of this, probably. I don't need this anymore. Okay, so we have our Star Wars data frame, and we have some character columns, which I do not remember off the top of my head. Okay, so there are columns that you see on the console, and if you want to change them, so originally they were all not uppercase, they were all probably just regular character columns with uppercase first letters and lowercase rest of letters. Then we'd like to select all the columns which are characters first. And in order to do that, inside a mutate function, we can use this where command and this character. So is character returns true or false? So it returns this is character returns true if a column is a character. Otherwise, it returns false if it's something else like a number. So if you looked at age and asked it, is it a character? The answer is no, so that's false. So that's not selected. So for all the columns where is character is true. So where this equals true. We want to apply a function to it. And we can do that by using in this very specific case, inside of tidyverse vert, like select or transmute, we can use this across function. So basically it's saying across all the columns where its character is true, again, where its character is true, apply the following function. So what is this function? This function is, string to upper. So across all these character columns, we're going to apply a function. Again, this is like a verb, a function where, string, that's called string to upper. I forgot to show. So basically, this where is character is shorthand for all the character columns, right? And then you can think of this as a placeholder for listing all the character columns. Then you're going to plug the character column one at a time into this function. So we set X to the first character column, and then we apply string to upper to that first character column. So we do the same in the second, and then the third, and so on until we hit all the character columns in the data frame. Okay, some more nods, that's good. All right. It might take a while to wrap your head around this across, but it's quite versatile. And it's what's being used in tidyverse now. So here's another example, again, of using the across. This one's a little bit more straightforward because we only use the following function across 3 variables. And this kind of confusing notation is just shorthand for a function x, where x, the function we want to apply is x equals x plus 1, or sorry, x plus 1, yeah. Are there any questions about that? Okay, if not, then you get to try out mutating and transmuting in the next exercise. So here, new column should dynasty their frame. And it looks like you'll have to use something called an if else. Maybe. Let me just think about this really quickly. So again, this whole section is about mutate. And we can define something called class. And okay, so in order to do this, you'll need to look up what if else does. Here's a function called if else. We might have gone through it in the last lecture, but it's probably foggy even if we did. So go ahead and look this up, and you can practice using the documentation. Yeah, so. Comments and only in filter.
Oh,
Try the ampersand.
That's close.
Yeah, so. Well, I think you're missing a emphasis somewhere. I think that's a state. Then that exits out of the try again. Try being in the that's no works too.
Yeah, I think. No, they're separate things. Are we supposed to? I don't know. Oh, sorry, I was gonna like. Yeah, so what we're trying to do is. One. And. Oh, okay, yeah, so what you need to do.
It's close. Yeah, it's you're also
What you need to do is-
close. Yeah, I think it's actually.
Cut is ideal.
Yeah, okay.
Right?
I think it's like.
We need to-
Oh,
so
and-
that's equals one. But you also need to kind of put parentheses around
So
the or statement.
is that supposed to be your
So basically it should, this thing or that thing.
condition? Yeah, so your,
Does that make sense?
that seems like what you want. So. If this condition is right.
Yeah. Like you're saying,
That's
whatever. Whatever working for me. Yes, don't put the or on it. The or goes out. Basically, like you have this thing or that thing together and then and something else. So it's still a little. This is good. And now.
Right, well, parentheses around this. So. Right.
That's good.
One condition. This is the.
Here's the condition.
Right.
And then if the condition is true, that's what comes after the next column. Right, you want that value returned, so you don't need X or one. You just need one.
Argument, yes.
There's just one. And then the next column.
Now I have
is the else. Right?
You should want to
So
do
it is a value, the truth, give you a one, or the value is false, it'll give you a zero.
I think you're.
That's what.
Yeah, I think that. So it's just. Just make sure you have your closing.
So the idea of
Because You have a closing one for the very first opening one right after. Your condition. Yeah. Yeah.
And then, something. And then we're.
It has to contain these two things to it.
Why is it keep cycling?
The one and zero, but right now it's stopping right after. the two.
Oh.
It's not anything.
I probably have to move.
Okay, so then.
Okay, let's take that one out. Okay, what if I did? Yeah. Remember that your first. Should be the. So it's class definition and more. Condition is one. So the only one condition. So that should be. Yeah, that's what that's, yeah.
Oh.
It's
Which would be like one here. Yeah, but I want.
How did I have it?
That sounds true. I thought this.
Okay, so we're gonna go through what the answer is. I know some people have it. Okay, so this if else. If you look at documentation, it asks for a test and then a yes value or a no value. So basically, if the test is true, it's going to return a yes value. If it's not true, it's going to return a no value. Anyone tell me what the test they put was? Yeah, great. Or premium. Yeah, great. And then. You're greater than 2. Okay, that's great. I just want to make sure to emphasize that the comma, didn't work for you?
No.
No, okay. All right. That's because the comma is specific to filter. Okay, yeah. This and is how I usually do now. And. So great, we have our test conditions. And if this test condition is true, we want to return 1 for class. If it's false, you want to make it 0. So it's good here to be very explicit about parentheses. So here you notice that I put parentheses around this or condition. So I'm making explicit that either this or this is true. And caret greater than 2 always has to be true. So make sure you have parentheses, correct the specified, and make sure you have opening and closing parentheses that match. I think I've done it wrong here. Okay, great. I'm just gonna do one more parenthesis because I don't think this looks correct yet. Okay, the fact that I'm still ending up with good cuts is not ideal. Hey Janice, you know,
We've got good.
where, I don't see it. Over here, third row.
Hold on.
Actually,
Well, you
oh,
have
that's because oh, no, that's fine. Oh, that's because I just muted class.
You just, yeah, you didn't take it.
Yeah. Okay, so we can look at class, which is at the very end. You can see lots of zeros. Let me see if I can.
Well, so you're, but, right, so you're not actually taking them out, you're not selecting.
Yeah, I'm not selecting.
Yeah, so they should still be there, but 0.
They should be. Sorry, let me just make sure I have both, 1 and 0 classes. Okay, great. So we have about 1,200 class 1s and a lot of class 2s. Okay, great. Does anyone have any questions about this? Yeah. How do you make the tibble appear again? The tibble. Oh, like this thing
Yeah.
over here? So if you press play or just shift control enter in my case, it should just show up underneath the coach over. It's okay. Okay, so we now know how to create new variables. And use the if else statement. Yeah, so now we can talk about how to summarize some variables. So now we can do things like take the mean, take quantiles, we can do fancy stuff and summarize certain variables. So we can use the summarize command to do this. And also some group 5 stuff. So here, what we're doing is we're going to look at the Star Wars data set. And we're going to find the average mass and a median age for all of the observations. So this NA.RM equals true means that we don't regard any missing data. We just ignore all of it. So again, let's run this. And we can see that the median age is 52 and the average mass is 97.3. So we can do this for multiple multiple columns by using the cross command again. So here, what we're going to do is we're going to summarize across all of the numeric columns using this where numeric term. And then we're going to take the mean and make sure that we remove all the NAs or the missing data in your set. Let's just see if this works. Yeah, there you go. Okay, that worked. So we can look at this, which is not updated in your script yet, but it will be. And we only have 3 numeric variables. And we've taken the mean out for all of them. So again, using, I don't know if I actually did this right. Okay, yeah, I did. So using a cross again, we can take the mean and the median this time. And here we can see that I think _1 corresponds to the mean and _2 corresponds to the median. And there are ways to rename these variables, but I'll probably go over that later. So let's say that instead of being interested in all of the, I guess, participants' means and median heights, masses, and years, we want to look at the mass by homeworld. So this means that instead of having one average mass, we'll have lots of average masses by depending on homeworld. So this would look something like this over here, where you can see that the average mass on, for example, LE minor is a lot smaller than the average mass on Bestine 4. So this group by function basically tells us what you want to group your summary statistics by. And this is very useful if you want to see if there's, for example, differences in mean or median between different treatment groups, for example, or different measures on different days, for example. Yeah, for instance. Okay. So given that, we can take the last 5 minutes to very quickly do some exercises involving summarize and group by for the diamonds data set. So remember to use both group by and summarize if necessary. And I think you have to use group by for both of these. All right, I'll give you a couple minutes and then we can go over answers. Okay, so let's go over the answers really quickly. So first you want to group the diamonds by cut and find a mean in each category. I think that means we just want you to find the mean. Okay. So first what we want to do is you want to group by cut. So we can do that using the group by commands. And then it says find a mean in each category. And means only apply to numeric variables. So I think what we can do is we can summarize across the numeric variables. So we summarize where the columns are numeric with the following function. We summarize the mean and we try to ignore all of the NAs. Diamonds with an S. So you can see that it looks like fair diamonds are have fairly larger mean carats than the others. And the price, surprisingly, is actually pretty similar, probably because we have larger carats. Even though the quality isn't as good. So now let's do the second problem, where we count the number of diamonds of each color. So what we can do in this case is we can group by color. And then we can use a function to summarize it called, I believe it's N. Diamonds. So this is a little bit of a shortcut because actually no, I think it's fine. So this function here, I guess it's just if you look it up, oops, it just counts and gives the current group size. So you know, should group by color. So it gives you the number of diamonds in each color. And the output looks like this. So we have most of the diamonds are G. Which I don't know if it refers to green or something, but something similar. Oh, it's just a grading. So G is like an okay grade. So another way of doing this is by using the count function. And it just is shorthand for the above. Group by colored and summarized N equals N. So these are some ways of, I guess, summarizing our data. And we can already see that we can make some maybe inferences about our data by looking at these summaries. For instance, for the first one, you saw that a lot of bare diamonds are actually pretty big. And that's why they're probably the same price as better cut diamonds. Okay, so I think next week, Richard, who you probably met last time, will be talking about plotting and using this data that we've cleaned to actually visualize results. So yeah, thanks for coming. This is the, I guess, overall summary of what we've done this week and last week, the week before last week. And we'll see you next week.